This video is going to talk about geometric postulates, theorems, and definitions, and how to take a conditional statement, identify which theorem, postulate, definition it is. First, we're going to start off with our warm-up. Number one, we have M as the midpoint of segment FG, and then we have some information. We're going to go ahead and first start off by drawing this. So we're going to have our segment FG with M as the midpoint, making sure we have our congruent markings. So we're going to have that the length of FM is 5y plus 13. The length of MG is 5 minus 3y. Because this is the midpoint and I have each part, the two parts are congruent, so their measurements are going to be equal. So we are going to set these equal to each other, and all they want us to do is solve for y. That is it. So we're going to take 5y plus 13 equal to 5 minus 3y. Variables to one side. I'm going to move my smaller variable. I need to add the 3y to both sides. Be careful that we are adding this time. So we have 8y plus 13 equal to just 5. Since my variable went to the left, the constant, the 13, needs to go to the right. So we're going to subtract it so we can zero it out. We will end up with a negative number. Bring down your 8y. 5 minus 13 is a negative 8. Okay, our last step, we're going to go ahead and divide. And we're going to see that the negative 8 and 8 do not cancel. It is not 1. We have a negative divided by a positive, so y is going to end up being a negative 1. Pause it and go back if you need to, please. At this point, we do go pretty quickly through the solving equations. Number 2, angle 1 and 2 are supplementary. Okay, and they have a diagram for us. Well, we know that supplementary, they're going to add to equal 180 degrees. So we're going to take your 2x plus the 4x plus 108 all equal to 180. First thing, we cannot do anything until we clean this side up. We need to combine our like terms. We have 4x's and 2x's, giving us a total of 6x's. And then our constants, it's just the 108. So we bring that down, equal to 180. Okay, variables are only on one side, so we need to get the 108 away from it. Subtract it out, get 72. Okay, last step to get x, let's divide. X is going to end up being 12. Now we are not done, because up here we're going to see we want the measurement of angle 1. So we have to do now at this point, we know the substitution property. So we're not going to say plug in anymore, we're going to say substitute in. So the measure of angle 1 was 2x. We're going to remove x. We're going to plug in what x was to find out that the measurement of angle 1 is 24 degrees. What we're going to do next is we're going to take a look at the postulates, theorem, definition page that we have that is separate from the notes packet, which I like being separate because you don't have to go flipping through your notes packet to figure these out. We are going to take these different definitions, postulates, and theorems. We're going to take a look at our conditional statements over here, and we're going to figure out what the important parts are in the hypothesis and the conclusion, so that when we go through the next problems in our notes, we can look for the highlighted places. Your segment and your angle addition postulate, what you are doing is a part plus part equals whole. If you do not see yourself adding two parts to equal a whole, it is not one of these addition postulates. We learned in chapter 1, and I tell my students all the time, with segment addition, you're looking for that word between. And then we have a part plus part equaling whole. Here's a part, here's a part, here's the whole. You may have the word between and then an equation, or you may have a diagram in the equation, looking like this, okay? Same thing with your angle addition postulate. This one, we're looking at the word interior. We don't say a point is between on an angle because we have all this area down here. We say it's on the interior of the angle. Again, we have a part plus part equals whole. Or, using the diagram, here's a part, here's your part, here's the whole thing. Okay? So again, we may just have here the diagram and an addition equation here. What we're going to do is we're going to look at the complement theorem and the supplement theorem. Then we're going to turn the page over and we're going to look at the definition of complementary angles and definition of supplementary angles so we can see the difference. With the complement theorem, we have never talked about a complement theorem before, okay? So this is new. The theorem is stating that if we have adjacent angles that form a right angle, then the angles are complementary. Make sure you're not highlighting anything other than what I am. Don't highlight anything else, please. Okay, there's a reason why. Now, with the right angle in the hypothesis and the complementary in the conclusion, or looking at the diagram, we are going to see that these two angles are adjacent. They are attached. Okay, well, let's flip over and look at the definition of complementary angles. The definition of complementary angles does not say they have to be a right angle. They do not have to be adjacent or connected. There's a hallway right here. These are not connected together. Okay, they can be, but they don't have to be. All the definition states that we have learned from a long time ago is that we have two angles that add to equal 90 degrees. Then we have complementary. Okay, seeing that difference. The theorem states we have a right angle. The definition, what we've been seeing since junior high, is 90 degrees. You're going to see the same thing. Sorry to keep flipping back and forth. You're going to see the same thing with your supplement theorem. It says they have to be connected as a linear pair, and they're supplementary. The definition, what we have known since at least junior high, only states that it's two angles that add to 180 degrees. So they're supplementary. Again, they don't have to be attached. The theorem, they are adjacent and connected. The definition, we have the numbers, right? Flipping back again, let's take a look at the vertical angles theorem. Your vertical angles theorem in your hypothesis or the conclusion, we can have the converse, okay? And I'll talk about that one with this one. If we have two angles that are vertical angles, then the angles are congruent, okay? Say in the converse, they may not put vertical angles first, then congruent. They may say if two angles are congruent, then they are vertical angles. Okay, keep an eye out for that, but these are the pieces we're looking for. Another thing they may give you is something like this, a picture of vertical angles, and that the angles are congruent. And these should not be there. Okay, so, vertical angles being congruent, vertical angles theorem. Next, we have the definition of the right angle. What we're looking for is right angle, 90 degrees. And they did write the converse here. Look at the converse. Converse switch. Right angle 90, now we have 90 right angle. As I did show you both. But right angle, 90 degrees, this is the definition. Over again. The definition of perpendicular lines can be very easy to see and identify as long as you know what this symbol means. That symbol means perpendicular. And when we have the intersection of perpendicular lines, there's going to be a right angle. But honestly, you don't need the right angle part. You just need that perpendicular symbol, and this will be the definition of perpendicular angles. I'm sorry, definition of perpendicular lines. Okay, let's move down and talk about the definition of midpoint versus the definition of congruency. What we're going to notice is, and I've been saying with my students since we started chapter 1, started dealing with congruent parts, when two things are congruent, their measurements are equal. We can also do the converse. When two measurements are equal, the objects are congruent. Okay? Now you're going to notice that we have the exact same kind of statement, a congruency state. Two things are congruent, measurements equal. Two things congruent, measurements are equal. So we need to be able to identify when is it a midpoint, when is it a congruency. And I had my students go and look at it, and I had them think about it for a minute. A lot of them were realizing what is happening. If you look at your congruency and equality statement over here, with the midpoint, you're going to notice they have a letter in common. That is the letter the point at which they connect. That is the midpoint. If you look at congruency, they don't share any points. If there's not a point in the middle, it's not a midpoint. So here, no letters are alike. So that is your definition of congruency. The last two we're going to talk about are your definition of angle and segment bisectors. What you are looking for here is the word bisects for both of these. If you do not have the word bisect, it's not a bisector. Also, when you're seeing the word bisect, you don't just get to choose whether it's angle or segment. You need to look at the symbols. Okay, here we have angle symbols telling us angle bisector. The next one we're seeing segment symbols. So these are segment bisector. Now, I also want to discuss here with your segment bisector how in the congruency and equality statement they still have that shared point. Okay? Do not get this confused with midpoint. The difference between segment bisector and the midpoint is the word bisect. If you don't see bisect and you see the shared letters, that is your midpoint. If you see the word bisect, we've got a bisector. What we're going to do now is we're going to take a look at number 3 and 4 on back to our notes, okay? And what they're going to ask us to do is that we're looking at number 3 and we're going to go back up to number 1 on the warm-up up here. And they're asking us, how did we know that segment FM was congruent to segment MG? So in that hypothesis and conclusion, we had some things highlighted, and one of the things is going to be in the warm-up, one's going to be in number 3. So what we're seeing here is the reason we knew these were congruent was because of that word midpoint. And if we look up here in this statement, we're going to see that shared letter. So the answer to this is definition, I'm going to abbreviate, of midpoint. Pause it and finish writing it down if you need to. Next, looking at number 4, how did we know on number 2 right here that we were adding two angles to equal 180 degrees? Well, over here, that's the definition of supplementary angles. That's literally the answer too. Supplementary angles add to equal 180 degrees. So supplementary on number 2, the warm-up, and 180 here. We go back over here and we look. Supplementary and 180 definition. And I'm going to start putting angle symbols, okay, when we get to angle words, just so you know. So let's take a look at the next page. This is kind of a weird way what we just looked at, but here's what you're going to be seeing. We're going to go very quickly through this. Number 1, you don't need this diagram. Ignore the diagram, okay? Let's go ahead and highlight our important things. In our if-then statement, if angle ABE is a right angle, then the measure of angle AEB is 90 degrees. This is why we highlighted what we did over here. We're going to look through and find where do we see right angle and 90 degrees on the same one. If we look through, I'm going to see right angle right here, but it doesn't say 90. That's why I don't want you highlighting this part, okay? Right angle, but complementary. So keep looking, and we're going to see, oh, there's right angle and 90 degrees. Definition of right angle. Here's your angle symbol. Next, I told you guys that this one you really don't need the hypothesis and conclusion with highlighting, but we're going to do it anyway. That little upside down T, we find that on this page. We're going to see that upside down T, right angle, definition of perpendicular lines. And I just wrote perpendicular. Okay, that's perfectly fine with me. Go ahead and pause it and get that written down. And then we'll take a look at the next one. We are seeing two angles add to equal 90 degrees. Then they are complementary. So there are two that have the word complementary. We have the theorem, and then we have the definition. We need the one that says two angles add to equal 90 degrees. This is what you learned a long time ago. This is the straight up definition. There's your 90 degrees in complementary. This is your definition of complementary angles. I'm going to abbreviate. If you need to write it out, please write out complementary angles. At any point, pause it. Next, we are seeing here that we have if a ray bisects an angle, okay, then we have two congruent angles. Okay, past bisect, we really don't need anything. It's one of two things. It's either an angle bisector or a segment bisector. It's one of these two. So we need to look at, do we have the angle symbol or do we have the segment symbol? And here we have the angle symbol. So this is definition of angle bisector. And I'm just going to put angle bisect for short. Go for it if you want to. Letter E, we are looking at segment DB. If segment DB is congruent to segment BF, then the length or measure of DB is equal to the length or measure of BF. So with these two, what we're looking at is either definition of midpoint or definition of congruency. Remember, what you're doing is you're looking for a shared letter. If they do not have a shared letter, it's congruency. If they do, it's midpoint. And we are going to see here, they have a shared letter. So this is definition of midpoint. And I am going to write down, abbreviated, what I call MDPT. Okay, MDPT for shortened, abbreviated midpoint. Last page, take a look. Okay, now we have a column of answer choices here. So it's one of these, nothing else. And then we've got these guys over here. There is one right here, definition of linear pair, that is going to be not on that other paper we just looked at. So I'm going to jump to the second one here, just get this out of the way. Here we have adjacent and form a line linear pair. Okay, we have another linear pair that's supplementary, supplement theorem. Here we're forming a line. It is not on this paper at all. So we'll go ahead and answer that one. So again, we're going to go through and we're going to look at the important words in the hypothesis and the conclusion. The first one here we have, if an angle is a right angle, then its measure is 90 degrees. We look through and find, where do we have right angle? Nope, doesn't have 90. Right angle, right angle, 90 degrees. Right angle, 90 degrees. So we have definition of a right angle. So we look through here and we're going to find definition of right angle at letter E. The next one, we already did the linear pair. We have that upside down T again, giving us perpendicular lines forming a right angle. Again, this one, know the symbol. You don't need to look through the page. We automatically know it's going to be perpendicular. Next, we have two angles are complementary. Then they're going to add to equal 90 degrees. So again, we look at our complementaries. Here's complementary, the theorem, but it says right angle. This one does not say right angle. It says adds to equal 90. Complementary, adding to equal 90. That is the definition of complementary angles, which is way down here at F. Then next, we have two angles adding to equal 180 degrees. Then they are supplementary. So we're adding two angles to equal 180. They are supplementary. Here's the supplementary, but it says linear pair. So this isn't it. Supplementary 180 definition. And that one is letter B. You can't see it on my screen, but it's the second one down on the left. Last two. We have two angles that are a right angle, form a right angle. So the two angles are complementary. So again, we have our two complementaries. Well, one, we just covered the definition, right? Complementary right angle theorem. And that one is letter G right here. And then last, linear pair. We have two angles that are a linear pair. Then the two angles are supplementary. Two angles are a linear pair. They are supplementary, supplement theorem. And you can't see it on my screen, but it's letter C at the top. Just go through, look over these highlighted sections, make sure that we understand what is what, and complete your assignment. Ask your teacher if you have any questions, or you can search YouTube for other videos if you need to.